topic of discussion is component-based model. It's a software engineering topic for class 12, both CS and IP. In this slide, you can see the components of a total project is created and has to be assembled based on its particular components. First of all, in our discussion, if we want to see what is component. A software component is an element that conforms to a software model and can be independently deployed and composed without any modifications. Now I would like to discuss software development process. We must look a process different from a product. It's a development process. Whatever steps we need to apply, through which it results into a product, and the products are outcomes of executing a process on a project. So whatever processes we have to apply, based on that our product's quality will be decided. So the whole software engineering process focuses onto the process, and proper processes will help achieve project objective of high quality product. If we want to get high quality product, we must apply proper processes. Now let us categorize software process models. Different process models can be applied in software engineering. Some of them are the waterfall model, then the evolutionary model, that we can say that prototype model, and the component based model, in which we have all the components and we have to assemble it properly by following a software process. Let us discuss the component-based software engineering. The short form is CBSC. Here the main issues are to assemble systems out of reusable components, and of course the compatibility of components. If we have to assemble, you have to be very careful about the compatibility of different components, whatever you are applying. Why we require component-based engineering? Because it increases the quality and maintainability of a software. I think you all know what is maintenance of a software. If you implement a software in any of the organization, you have to give the foolproof maintenance throughout the lifetime of this software. Also, it increases productivity. And of course, it shortens the development time. You can say these are the different advantages of component-based software engineering. Okay, now the component model. You can say it defines the types of building blocks and the recipe for putting them together. More precisely, a component model defines standards for properties. The properties that all the individual components must satisfy, and the methods and mechanisms. More briefly, you can say that these are what and how of the components. The different component forms. You can go through the component development through different stages. It is the development phase, then the packaging, distribution, then the deployment, and lastly the execution process. And all through these stages, components are represented in different forms, such as during development, you can say in unified modeling language, you have different components. That is a development phase. And while packaging, for example, in a zip file, and at the execution stage, we have blocks of data and code. One of the important aspects of component object model is to hide the component internals. So that's why we have different types of specification. We can categorize them into black box, glass box, gray box, and white box. Black box is that particular component where only specification is known. Glass box where internals may be inspected, but you cannot change anything. In the gray box, part of the internals may be inspected. Limited modifications are allowed. While in white box, component is open to inspection as well as modification. The developed components can be assessed. If you want to assess your components, you first get the components, then you have to verify whether they are fit into your software specification or not, and then you have to store your components in the repository to use for future models. Here is the summary. To summarize, we can say that the components are composed. They must be compatible to each other. All the components must be compatible to each other. Then the development process should be separated from one component to another. Assembling of the system out of components. Then an architectural plan has to be organized so that they can be interfaced together to meet quality requirements.